Thank you for the introduction. So, welcome to the talk, Kubernetes Security and How to Bypass It. Yeah, I'm Benjamin, as introduced, and I will guide you through that talk. And yeah, hopefully we have a great time doing so. I think we kind of can skip the UMI part. I think everything was basically said. Maybe let me note that I also organized the DEF CON CTF this year. So those of you who know DEF CON may know that's a large security conference, and I co-organized the DEF CON CTF together with Jay. And you can find me on Twitter under my handle, Paketo, or Packet0. Okay, about this talk, so I only have 12 slides, something like that. So the talk is mostly demo, 60 to 80%. I only will give you a short introduction into the topic. We will have a look at some bug types, and then it's demo time. So 3 slides per topic, max. And everything needs to be open source and within the CNCF, what I will show you. And I want to put a disclaimer here. So no of the shown software is bad in any way. I will demonstrate some things, how you can bypass some things, and how stuff works in Kubernetes. And the software is not bad. You can improve it, open a pull request if you think it's bad. I mean, that's how open source works, right? Okay, so let's head into the first topic, which is basically role-based access. I guess you all know role-based access in Kubernetes. It's basically regulating access to the Kubernetes API. That's why we need it. And you can basically define who can do what. So, for example, if you have different teams or different users, you want to grant those teams or users different permissions, then you need role-based access in order to control who can do what. Okay, let's look at the bugs we expect to find there. It's mostly misconfigurations. I mean, it's quite simple. And I put the post here from Ian Coldwater. You may know they said, basically, we are all made of stars, but your airbag shouldn't be. That means that you have a star permission in airbag, and you should not use it. Because if something is added to the airbag group, then that is used also for your star, and maybe there's something possible with it. I will show you later. Okay, and let's head into the demo. That was the introduction for it. I have a Kubernetes cluster running here, which is basically a cluster that's prepared with some resources we may need also later. And here's the RBAC demo namespace. So for those of you who are interested, this is a kind cluster running locally on my machine. And there's the RBAC demo namespace here. You see that right here. That's this one. And when we switch into that namespace, so I'm already in that one, we can see the relevant resources for that demo. I hope everybody can read it. So if you cannot read it or if it's too small, please raise your hand and I can resize it. Okay, so I guess everybody can read everything. That's great. Okay, let's head into the first demo. So basically, I prepared some things. So there's a secret holder pod. Let me show you what it looks like. Here's the namespace that I created. Here's a secret I created with a password. It's a super secret password. That's super secret, right? All of our passwords should be. Then there's the deployment. That's the secret holder pod I mentioned earlier. And what it is, it basically has the secret mounted, right? Here's an env variable specified, and there's the super secret password mounted from that secret. So far, so good. Now, what we want to do is we want to give somebody permission on this namespace to, be a pod admin, right? He needs to create pods, get pods, look at the logs of pods and everything, but he shouldn't be able to see our secret. So I defined a service account called pod admin, and define a role here. You can see its resources are pods and pod logs. So we have, he has basically access to pods and the logs of a pod, and he can get, list, watch, create, and delete the pods. So I don't give the pod admin any access to secret in my roles, right? Okay. What we also have here is another pod, a normal Alpine pod. Whoops, I need the Alpine one. And what we see here is that this Alpine pod should use the service account. Yes, this Alpine pod has the service account mounted. So if I exec into that Alpine pod, I have basically the permissions of that service account, right? So let's exec into it. So I have kubectl pre-installed. So for example, I can do get pods. And to show you that I have like the real permissions, we can do kubectl auth can I -- list. And you see that the current service account this pod has mounted has the permissions on pods to like have a look at the logs and to get, list, watch, and create or delete logs. Our goal is now with this service account to get the secret earlier created. And I prepared something for it. It's basically a pod YAML that we have here. So what we can do is, if we know the name of the secret, and we know the name of the secret, because what we can do with the service account, is we can do kubectl get pods, and we have the secret holder here, and I can do kubectl get pods or describe pod. That's a little bit, the output is a little bit better. And what we see here is that there's an environment mounted. The key password is used from the secret, super secret. And I can use that information in my own pod to create a pod for myself, mount that secret into that pod, and because I can read logs, I can print this environment variable and just read the logs, right? And that's what we're going to do. So let's have a look at the pod YAML again. What I do is I create a new container, also an Alpine one. I specify the command. I only execute the command env, which basically prints every environment variable available in the pod. And then what I do is I also specify a secret here, or I specify an environment variable, also pass, and it's from the secret super secret with the key password. So basically, I just mount the secret, or like mount the secret as environment variable into my pod and print the environment. Okay, let's do it. Oops. Don't have the alias here. And now you see that there's like the secret holder new pod that's like completed. That's the pod we created. And if I do logs at that one, you see that there's the environment variable pass with the super secret password, and that's how I can, that's how I can leak, secrets when I'm only like a normal pod admin, right? That's something we usually see when we like audit clusters, for example, that the companies don't want us to like have a look at the secrets or don't want to give us the secrets or something like that. But with like permissions to create a pod, you can get every secret that's possible, at least if you can create a container in that specific namespace and have like access to, for example, read the logs or have internet access and like do a reverse shell or something like that. That's then purely possible. Okay, that's for the first demo. I also have a second one, which involves a secret. So basically, that's a quite funny thing, because we talked about it in SIG security, that if you define a secret, there's also a last applied configuration. So for example, I have a secret here, which is basically a very simple secret. And if I apply that one, and have a look at it, you see that there's an annotation added, right? This annotation is not added by me, it's added by Kubernetes. And what you see here is that inside of this annotation, there's the secret data. This is the exact same data that we specified over here. It's the last applied configuration. We need that in order to do like rollbacks and everything, but keep that in mind. If you specify secrets, your secret value is not only in the data field, it's also in the metadata. And that means if you, for example, lock your secrets or export them to some external service or something like that, if the service gets the metadata, it gets basically your secret data. I mean, it's not the up-to-date secret data, it's normally the last applied one. So basically, if I change the secret, this one here is the last applied configuration. But it's still secret data, right? So keep that in mind if you're using secrets. Okay, then that's for the role-based access demo. Then let's have a look at runtime security. So most of you may know what runtime security is, or hopefully use it. And let me specify for those of you who don't know what it is. So basically, with runtime security, we can detect or block, for example, if a process in a container is trying to access a file it really shouldn't access, Or we can find or detect or block like execution of a malicious program. We can block network connection of a malicious IP. We can do this with privilege escalations, or we can detect or block like known vulnerabilities, such as, for example, Log4j. There are like various runtime tools out there, for example, like Falco, Tracy, and also the newest one, Tetragon, from Isovalent. They're also here at the conference, so check that out. And they're also, or what we are expected to find for bugs here is mostly like misconfigurations, because every of those named tools has their own like policy model where you need to define, for example, specific policies for Falco, for Tracy, for Tetragon and everything. And if those policies aren't like sharply hardened, we can bypass it. It's normally you can, I mean, we didn't have any customer where we couldn't do it. So it's quite hard to write policies in order to detect everything inside a pod. Okay, then we can also write some rules that maybe tamper with eBPF. That's quite interesting. If you have eBPF tools and you can write a specific policy, you can try to tamper with the eBPF verifier. That's a quite like complex thing to do, but it's possible. I won't demo it here because it's like super technical, but it's possible. Then we can expect to find denial of, or if we find a denial of service, we can expect a node outage to happen, because those tools are normally like really deeply integrated into the Linux kernels. And yeah, because when those tools then crash, we can expect a node outage to happen. Okay, let's head into the demo. What I have prepared for that is basically I will work with Falco here. Let me go into the namespace. Oh, yeah. So, no, let me first show the installation. It's basically a really standard Falco installation. It's Falco running on my machine. It works as expected. So let me go into the demo namespace. It's the runtime demo one. There is also an Alpine pod prepared, but I need to have a look at my commands. What I need now is I open a second terminal and we'll show you the Falco logs. Let me do that, resize that a little bit, that we see what Falco logs for us. So, yeah, don't be confused. There may be stuff running through the right side of my screen right now. That's mainly because Falco logs some things, but I will show you the logs that are important to us. So normally what happens if I now try to exec into this Alpine pod is I get a message from Falco that a shell was spawned. Yeah, that's what I meant. Wait a minute. Let me do that again. Right. A shell was spawned in a container with an attached terminal. So Falco like detects that there's a shell running in my container, and it knows, okay, there's someone having code execution in the container, and it just throws like a log message out. But what I can do to bypass it, really simple. So now I can like execute my commands and nothing happens anymore in Falco. And what I can do to bypass it is I can not execute sh inside the container, but I can execute the command directly. For example, if I do ls, yeah, that was a bad one. That was unlucky timing. If we do that again, you see if I execute ls inside of the container, you won't get a log message from Falco. So if you want to fly under the radar, you won't you will not create a direct shell inside of your container. You will just use the commands one by one and do kubectl exec with the command on it. And Falco, won't detect it. Maybe you notice on that one, Falco is running like with the default policy set, so there are no like extra policies created by me. And that's basically why this one works. No, that's the wrong one. Okay, so let's have a look at another one. So for example, what I also can do is if I have a look at sensitive data in a container like etc shadow, for example, right? Falco says, okay, wait, warning, sensitive file has opened for reading. Go have a look at it. I mean, yeah, that's quite good that Falco does it, but what I can do, I can just do or have a look at that file, basically, of the process I spawn in the root file system on the etc shadow, and it won't show a message anymore. So Falco looks for a static file path instead of something from the proc directory. Okay, and then what I can also do is if I exec in that container, really quick, I have prepared a symlink in that container. Yeah, so I have a link here that points to etc shadow, and if I going to cut that symlink, I also get no message, right? Falco doesn't detect whether a symlink is showing to a sensitive file. It only shows a message on creation, basically. So if you can deploy a custom image with a predefined symlink, you have basically you can bypass the Falco detection with the standard policy set. Okay, so let's head back into the slides. And if you want to know more about Falco, there's a Falco talk actually also on at this conference. It's here. It's from Aisha. So go to check that one out if you're interested in how to build Falco policies that are more secure. Okay, and let's head into admission controllers. So what are they? I think those are 4 slides, so sorry for that, but let's head into admission controllers. So admission controllers are basically, they act like kind of a bouncer for the Kubernetes API. So we have mutating, we have validating admission controllers. Mutating admission controllers mutate stuff. So you throw a manifest against a mutating admission controller, back comes another manifest that's mutated by this admission controller. And we have validating admission controllers that basically validate your manifest. So for example, you could use that one for your compliance or whatever security that validate manifests. Okay, why do you need them? As I said, for example, we can disallow privileged containers, or we can disallow containers to run as non-root. And those admission controllers are also often used to validate custom objects, like CRDs. And I demo a bypass for run as non-root, which is basically a 0-day. Show you right now. But what bugs can we expect to find? So first of all, there are misconfigurations. If an admission controller is not configured correctly, then I can bypass it, as is given here. Then we can maybe have a look at parser differentials. So that's quite interesting. If the admission controller uses a different YAML parser than the Kubernetes API uses, then I can maybe throw a YAML manifest at the admission controller who says, okay, that's or I can pass the admission controller with that one, and that manifest is still valid for the Kubernetes API. So it's like a confusion between 2 different parsers that parse the YAML differently, and I can bypass maybe an admission controller abusing that. And then we may have a denial of service. So as you know, an admission controller has a failure policy. It can be set to ignore or to fail. And if an admission controller has a failure policy of ignore, if I can DOS that admission controller away, for example, I'm throwing too much requests at it, then basically that admission controller will let every manifest go through if that failure policy is set to ignore. If it's set to fail, then if the admission controller isn't reachable, Kubernetes will block the manifest from being deployed. Okay, so let's head into the demo. For that demo, I have Kubernetes installed, which is also, oops, let me close that one. I have Kubernetes installed, which is like the standard admission controller. You all know it. And I have a specific namespace for it, which is the admission demo. Here it is. So there are currently no pods running, which is expected for that demo. We have Kubernetes here. OK. What I want to show you now is, first of all, when I deploy a standard Ubuntu pod, yes, this deploys just the standard Ubuntu pod. You can see that the container is running. And if I exec into that container and do, for example, ID, you can see it runs as root. So that's what you normally don't want to have. So therefore, we can create a policy with Kubernetes. Right? This is like standard Kubernetes policy that says, OK, everywhere where you can set run as non-root, set it to true. And run as non-root basically allows the, or run as non-root blocks every container from being created when it's run under the root user. So let's apply those manifests. right? And if I now want to create the pod again, I need to do -- force. Ubuntu images are slowly in delete. And I create that one again. You can see that it's blocked, right? Because I didn't explicitly set run is on route to true. Okay, then let's do it. I also have prepared that one. This one is the exact same container as the above one, with only security context set to run is on route true, and the name has changed, yes. But otherwise, it's the exact same. So let's deploy that one as well. And you can see the container's creating, and now we're getting like this container or create container config error, which basically says, okay, you have set run is non-root to true, but the image will still run as root. So Kubernetes checks the root user of the running or checks the user of the running container and finds out, oh, it runs as root, so I'm going to block it. What we now do is we go to bypass it. Sadly, I cannot disclose how that one works like in detail because it's not like publicly disclosed currently. It was reported by me and a colleague in December last year, actually, and it's not fixed until that day. So yeah, there's a bypass for run is on root, and I will show you how that one works. Or I will just demo it to you. Cannot show you how it works, but you may see it later when I give a talk about how that one works. I mean, not here, but maybe at another conference, so we will see. If I deploy that pod, you see that there is an exploit pod running. You can also see I'm explicitly setting run is on route to true, right? And you see I don't have an Ubuntu image anymore. I have like my own research image for it. So don't try to pull it. There's a full secret for that one. You cannot do it. And if I exec into that pod now, you see that I'm still running as root, although I haven't set run is on route to true, right? Yeah, that's a bug in Kubernetes itself. And what I can do is I can bypass the Kubernetes mission controller abusing this bug. And we can expect more bugs like this to be happen in Kubernetes in the future because it's like a huge code base and it's very, very hard to secure it. Okay, but I don't want to leave you here with like thinking, okay, like everything in Kubernetes is bad and security is hard and everything. I also have prepared other admission controller policies for the demos before. So let me show you how we can like prevent at least a little bit of stuff I showed. So for example, for the RBAC one, we can deploy a policy that, for example, disallows secrets from being used in a manifest. If we talk about Kubernetes security, normally or ideally, you shouldn't use secrets. That's mainly because secrets are very, 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 very hard to secure. Also, if you're using like a vault or something like that, the exploit still works because, I mean, yeah, it still works. And also, if you're in the cloud, you must think of every object that you can query through the Kubernetes API is located in etcd, and it's basically the same. So we had that one in crypto, not your private key, not your coins, right? In Kubernetes, it's not your etcd, not your cluster. And basically, that's for every managed cluster out there, you don't control the etcd, right? And everybody with access to the etcd has basically full access to the cluster. So and all of your secrets that are in Kubernetes are in your etcd database. So basically, yeah, you need to like you need to be very confident with your cloud provider or something in order to like host your Kubernetes cluster over there. So if it's possible, don't use Kubernetes secrets. Mount them if it's possible. So like yeah, and don't use them as end variables. But let me demo how that one works. So if I apply, oh no, not the secret, I need the policy. If I apply the policy here, and I exec into the, oh wait, I need to change the namespace, otherwise this will not work. So if I exec, yes, into that pod again, and let me delete that one. So, and I now want to like create my pod that basically like dumps the secret. What I can do is I do like the apply, but it doesn't work anymore. So now Kyverno basically has blocked the creation of the pod because I'm using a secret. I'm not allowed to use a secret. So yeah, it's basically blocked, and I cannot abuse this one anymore. Okay. Then let's head into the policy for the Falco one. So that's like a really simple one, and the one that's like not 100% accurate because it's also a Kyverno policy. And everything I showed, how you can block it, is basically like you reject exec into a container. So you cannot execute kubectl exec anymore. It's not allowed. That's what you can do, for example. I mean, you should, in addition, have proper Falco policies deployed. But also, if we apply this policy right here, and we try to, exec into that Alpine container, you see that I'm not allowed anymore to exec in that container. So basically, I cannot do anything of the things I showed you before. I cannot do anything inside the pod. What I still can do is I could like deploy a custom image and bypass it by that. I can set a specific command for it. Yeah, that's something I can still do. But yeah, at least we want like a little bit of security. Okay, that's with that one. Yeah, and that was basically my talk, Kubernetes security and how to bypass it. I hope you learned something. I hope also that yeah, you could take away from that talk. And yeah, Kubernetes security is hard. I hope, yeah, I could tell you it a little bit. Also, if you have like any questions or something, you can email me. I will answer for short questions. I will answer them no matter what. And if you want to contact the company Neodyme, you can just write email at contact@neodyme.io. So thank you very much.
Thank you very much, Benjamin, for that very exciting talk. And we have enough time for questions. Right, Matthias?
So you were showing regarding runtime security.
You have to talk into the...
Oh, sorry. There, perfect. Do you hear me? Perfect. So you were talking about runtime security.
Yes.
Especially you were showcasing Falco and its, let's call it, shortcomings. So I wonder what's your general take on runtime security tools? Do you say you have to write your own policies for them in order to use them? Is that what's basically, because it looks like it's not doing what it should, right?
Mm-hmm. I mean, you can use them without policies, but that's like a bit clueless. So yeah, you should write your own policies. There's also something in Germany, or a group in Germany with like a beautiful German name, Interessensgemeinschaft zum Betrieb von Containern, and they have basically like default rules that allow with some of our German, yeah, rules or politic stuff that we have, and they have like a default or good default rule sets which you can then apply. But writing policies is really hard. Writing policies is always very individual. So normally, if I write policies for my environment, I cannot pass them to you and say, yeah, those are good policies, right? So you should, yeah, take your time and write good policies. Yes.
And the second question would be, have you played around with Tetragon, which is another player in the space? And
yes, Tetragon is very nice because actually, like Falco in the open source variant is only detecting. You cannot put it like into blocking mode. And Tetragon has the thing where you can like override the return code that's basically like coming from the kernel. So you can actually also block things. And Tetragon locks a lot more by default. That's also very good, right? So you install it and you see a lot more events than you see, for example, in other tools. Yeah. But you still have the problem with the policy language there. You need to like build your policies. Yeah.
Thank you.
I think Jonas had a question.
Thank you. You said don't use Kubernetes secrets. If you could start a new environment, no constraints from the organization, where would you store secrets? What would be your process? What's your favorite tool? And how would you consume them in a container?
Ideally, you have, ideally you use a CRI, not a CRI, a CSI, Container Storage Interface, or a plugin for it. And you store your secrets on that CSI. So for example, let's say I use a NetApp for storage, and I want to use secrets. Then I go ahead, I provision the volumes with my secrets, and then I only mount the volumes to the pods. And then I don't have anything to do with the secret API, right? Because I only use volumes to store my secrets. That's the ideal thing. But it's also quite complex to do that in production because most apps are dependent on environment variables, right? So what you need to do is you need to put a piece of software in front of the main app that reads everything from the volumes and mounts or puts the secret from the volume into the environment or mounts it as environment variable, right? That's something you could do. There's something called Summon, for example. They had a really nice approach. I think they were bought by the other Vault vendor, not HashiCorp. The CyberArk guys, the CyberArk Vault guys. I don't have the name in my head currently. What they do is they mount a secret into the process environment of a process. So if I do env inside a container, I won't see the secret because it's only in the process environment. That's really nice, but also all of those workarounds, they also come with a lot of work and a lot of effort in order to execute it correctly. So, you should consider, what's the best for your solution for your app, because you can use the volumes and no secrets, but then your app doesn't work. So it's like a trade-off, right? You need to.
Thank you.
Any more questions? So, yeah.
Oh, sorry.
So in the past, we used encryption at rest for secrets. So basically, they are encrypted before they are stored in etcd. But as far as I remember, this is a configuration you have to make in the API server, basically.
Yeah.
So do you know if that's possible with the managed offerings from the 3 big cloud providers?
Yeah. Let me tell you something about the encryption at rest thing. It's quite funny because encryption at rest in Kubernetes for etcd works. You write your encryption file. Basically, the keys are defined in it. You define some encryption keys. They are base 64 encoded. And you need to put that file on side of the you need to put that file next to your Kube API server. Yeah. So the API server needs that file. At the same time, most of you, I think, won't use an external etcd cluster to operate your cluster, right? It's normally the etcd database is is at the same node where the encryption config is. So as an attacker, if I can dump your node, I will dump the encrypted database, but I will also dump your passwords. So that's basically completely clueless. What you can do, there's a KMS interface. There's KMS interface v1, which is deprecated in, I think, 127, and then there's v2, which is now, I think, in the stable version. You should use KMS if possible. The problem with this is that if you want to use, for example, HashiCorp Vault, it doesn't support it natively because the KMS interface somehow is an interface that's like a Unix interface that's local on your node, so you cannot connect over network to this interface. What you need to do is there's a solution for it called Trousseau, which you need to connect between your Vault and your master node to do it with KMS v2. That's not ideal, and that's a lot of effort to put into. The cloud providers, on the other hand, they have implemented their own their own implementations of this interface, and they integrate really deeply with their own cloud stack. But here's the thing: the thing is, you need to really trust your cloud provider that the encryption or that the plugin they implemented really does the job right. And for example, for most cloud providers, another problem is that you can only encrypt secrets. You cannot choose to encrypt everything. So in a normal encryption config, I can choose which resources I want to encrypt. I can do, for example, I can encrypt every resource, right? When I have a cluster in the cloud, I normally can only encrypt like secrets or something like that. Mostly I can only encrypt secrets, not something like that, only secrets. And I think that's also kind of a problem, because ideally you don't want your cloud provider to see like everything. I mean, why, right? It's not on their interest, or it shouldn't be.
Thank you.
There's one more question here. Let's see.
So one question, the game is always to gain root access with the container. I've seen some initiatives towards user space containers. What do you think about those, and how do you compare that to using kata containers, for example?
Okay, so first of all, the user space container thing. There is, or in Kubernetes version 130, there was introduced that the kubelet can now use user namespace in order to execute your containers. So basically what that means is, if you specify a user inside of your container, I'm only the user in the container, but on the node, I'm still root. So if I try somehow, I try to escape from the container inside the node, I'm always root on the node, because the process runs root on the node. With a user namespace added, we basically have like a user ID mapping from the node into the container. So if I'm now in the container user, let's say, user ABC or something like that, if I escape from that container onto the node, basically I'm also another user on the node. The best thing would be I would be a user over the user ID 10,000. Then I would be user nobody in the group, no group. So at Linux, I cannot do anything. I think that's very effective to mitigate container escapes. And yeah, it's natively possible now in Kubernetes version 130, I think it is. Yeah, so definitely do that if it's possible and if you know what you're doing, because the potential is there that some things break. At least when I tested it, it was like that. So, and what was the other question? The other
question was that compared to kata containers.
Yeah. So kata containers, what they do is they build like a short they work with like KVM. And they build like a little virtual machine inside of a kernel and deploy one container into it. They have like these nice proxy where they like proxy all of the traffic into that container. So for the user, it feels like you're using still a normal container runtime interface, but in reality, you have like a small VM with only one container running inside of it. I mean, you have some disadvantages because of that, because I mean, obviously running a VM is like more will cost you more than running only a container, but you win security. That's always a good thing if you, for example, if you talk to a regulator and they say, no, you cannot use containers, they have like a bad isolation compared to VMs, then you can say, okay, then we use kata containers. Then we have basically VMs with one container in it, and then, yeah, they cannot argue against it because you're using VMs, the technique you used before. So that's a good thing to do. So if you want to isolate containers better from each other, kata containers is very good. And there's something even better, which is like confidential containers, which is kata containers basically on steroids. What they do is they encrypt your memory in this VM. So even though, you have a VM running, if someone can dump the RAM or the memory, they can read everything inside the memory, right? So and if you have encrypted memory, that's not going to happen and not going to work. So you can also check that out. It's also open source, it's confidential containers.
Cool, thanks.
So we have time for one more, or should we?
Thank you for your talk. Because there is so much cognitive overload these days when you're running Kubernetes, and also security guys, they're already so busy. So who defines the policies, and how are organizations going about defining these policies, and how do you decide what should be defined and translated into the Kubernetes world?
Yeah, that's very complex, and that most of the time that doesn't work, because I can tell you that most security guys don't have any clue about Kubernetes. It's normally the thing where the IT security department of a company, like for example, I give trainings and they join the training and they say, oh yeah, we're running like 500 Kubernetes clusters, now we start thinking about security. That's a bit late, right? and you see that they have never worked with Kubernetes, they don't have like any clue of it, and that's then quite hard to define policies for it, because I mean, how are you going to do it, right? So most of the time, I kind of recommend to either do it with somebody who's like an administrator, an administrator of Kubernetes clusters. That they like pull this guy out and say, okay, how does it work? How do our workloads run and everything? And then you can try to like dump the, let me say, or call it like runtime config. So for example, what binaries are used in the container? What network connections do you use? And those things, right? What files do our app write and reads and everything? This is not something that the security guy knows normally. This is something your developer knows, right? Or your administrator of your cluster knows. And if he tells those information to the security guys normally then can say, okay, then we watch this file that we write, right? Or we watch other things. Or we only allow that specific binary then, if only that binary is run, right? That's the process I normally recommend. In practice, this is also sometimes hard because, for example, if you install a Helm chart from an external source, normally your administrator of your cluster also doesn't know which files do, for example, if I install Harbor, which files does Harbor write and read? I don't know. I mean, right? It runs, so I don't care. That's also sometimes quite hard. So yeah, if you develop your own software, you should definitely, I think you should do it like that. But I mean, it's different for every company, right?
Thank you. Really appreciate it.
There's one more just behind you. I think that's the last one we can take.
So we talked about container security with user namespaces before. How about mandatory access control systems? So AppArmor or SE Linux?
Yeah. So I always recommend our customers to, if they want to migrate, for example, from normal Linux VMs to Kubernetes, normally most companies have like a company policy that says, okay, you need to use AppArmor in order to run your app, or SE Linux, something like that. And what you can do is, you already have some profiles, right? You define some profiles. So why don't you just test it and like run or take the app, migrate it to Kubernetes, and apply the same profile inside of Kubernetes? That might not work every time. At least that works, sometimes. But you can then just like, you can build on that basis, right? I mean, it's very important to have those profiles, if possible, if you have somebody who can like write these profiles, because that's another policy language, right? So you have the policy language possibly of Falco, of Kyverno, and then you have the policy language of AppArmor or SE Linux. So that can be like quite hard to I mean, you want to deploy your app into production, not writing policies, right? So that can be like sometimes quite hard to define the correct policies and everything. But I would agree if you have a guy that or a girl that knows how to write those policies or to write those profiles, just let him write the AppArmor or SE Linux profiles. I mean, they can also do a lot of stuff security-wise.